Alright, properties of logarithms. This is going to be the third of the series of videos that I promised you guys, so here it is. Just want to remind you that these are the rules that we've been discussing, and these are the rules that we can apply. And people get kind of confused, like, if I see this, I have to do this. No, man, if you see this and it's convenient or helpful to do this, go ahead. And also keep in mind that if you see your equation set up in this way, you can run it back this way. Whatever's most convenient for you, whatever helps you get the problem solved. So it's not like, if I see this, I must do that. It's what works best with me. And as we get better and better at math, we're going to get that. So I know a lot of you are going to be very, very skilled mathematicians in your lifetimes. So start to work on the idea that, is this something I need to do given any particular problem? So if we were asked to solve a problem like this, if we were asked to simplify or expand a problem like this, right, it look like this: this log base a of square root of x squared plus 1 over x cubed, I don't know, x plus 1 to the fourth power. Not what must you do, but what could you do if you were asked to expand this. So we're talking about expansion here. And if you're taking Cal right now, ask yourself, can you simplify this? Can you put this in to an integrable form by doing this? And sometimes that is key. So that's how this will help you in AP Calculus or Calculus 1 or 2 if that's what you're taking now. So this is what I'm doing. I'm just going to start breaking this out. I'm going to look at rule number 2. I'm going to look at rule number 2 because I noticed this solidus, this division bar, and that division bar right there is this one right here, isn't it? So I'm like, okay, I'm going to take this. So I'm just going to start my rewrite and say I'm going to take log base a of the square root of x squared plus 1, right? And then it says minus. This minus sign is this minus sign. I'm going to put these brackets like this, and I'll show you why in a second. You don't have to use this shape. For me, it reminds me that I have unfinished work. So I'm going to take log base a of x cubed, right? I'm down here at the bottom. These things are being multiplied, so I'm going to do plus down here, plus log base a of x plus 1 to the fourth power. Right? So I'm just kind of holding on to this for a second. Otherwise, it gets really confusing for people. So that's why I'm using these square brackets, because I had to do two things. The solidus, the fraction bar, forced me to use the negative sign. But then in the denominator, we had multiplication, which forced me to use this rule, right? So, excuse me, this multiplication sign here forced me to use rule number 1. Hopefully you can see that. I'm going to start cleaning things up. I'm going to apply rule number 3 here. So I'm looking at rule number 3. I have things raised to exponential powers. One thing I'm going to do is clean this up. I have the square root. Remember, the square root is the same as 1/2 power, isn't it? So hopefully you can see what I'm doing here. I'm going to take this 1/2 power. I'm going to roll it back to here. So I'm going to get 1/2 log base a of the argument x squared plus 1. Now look for a second. Somebody's going to think, well, can I roll this square back here? No, because it's part of the argument, and the argument is x squared plus 1. So these parentheses stop you from doing anything with this one, okay? All right. Then I'm going to keep my minus sign the way it was. I'm going to simplify this. I'm looking at this exponential value here, thinking about rule number 3. And I'm going to take this and I'm going to roll this to here. So I'm going to get 3 log base a of x, right? So I got that part done. This plus sign is this one. Then notice this 4 here. I'm going to roll this 4 back using rule number 3. I'm going to roll this 4 back to here. So I have 4 log base a of x plus 1. Now, just to complete this, to clean this up a little bit, what I'm going to do is I'm going to go ahead and distribute this negative sign, right? Because if you look at this, this whole thing is in the denominator, and this is forcing into the denominator, right? But I can clean this up a little bit. So what I'm going to do is I'm going to distribute this like this, just so you see where I'm going. I'm going to take this, distribute it to here, and to here, right? As I do that, so I have negative times a positive is a negative, isn't it? So I'm going to take these parentheses down. I'm going to multiply this negative times a negative is a negative. Remember, where there was a negative here times this positive is also a negative here. And I can take down my brackets. I can clean up my diagram for you. All right? So this is the expansion. And what we did here was we used the sum. We expressed this as the sum and difference of logarithmic functions. All right? So again, going back to it, look, you guys, the most important part is know the three major rules and apply them. And just take your time. You're going to get really good at this. Be methodical. Be really good. Take your time. you're going to be great at this, and this is going to lead to a lot of really good stuff for you. So if you have any questions or comments, please let me know. If you haven't already subscribed,